half a boy, it's a ratio.
Horatio who?
Not Horatio, a ratio. It's mathematics, arithmetic. Look now, Opie, just forget that part of it. Forget the part about the half a boy.
It's pretty hard to forget a thing like that, Bob.
Well, try.
Poor Horatio.
Hey guys, and welcome to the Kearney Math Show. Just taking you back to our first discussion of ratios. If you would, before we get started, go ahead and write at the top. This is entry number 5. And we're going to be talking about proportionality. So what does it mean for two quantities to have a proportional relationship? In order for two quantities to have a proportional relationship, there is a constant rate of change between the two quantities. So for things to be proportional, that means you've got to be doing the same thing throughout. There's a constant rate of change. For example, driving at a constant speed is a proportional relationship, because if you're going 60 miles an hour constantly, that means in 2 hours, you should be able to go 120 miles. In 3 hours, you should be able to go 180 miles, and so on and so forth. Proportional relationship looks like it's just a constant rate of change. Now, there are 4 ways that you can determine proportionality. One way is ratios. You can look and see if the ratios are equal. For example, 1/2 and 6/12. Are they proportional? So you can look and see what's the constant rate of change. Here we're multiplying by 6. Here we're multiplying by 6, so they are equal. So they are proportional. So equal ratios are one way to determine proportionality. Another way is you're sometimes given a table, and this is a very common question. You're guaranteed to see several questions just like this on the calculator and active. When you're looking at a table to determine if it's proportional, it must have the same rate throughout the whole table. Okay, for example, if you're given a table with X and Y's, and we have 1 and 3 and 2 and 6 and 5 and 15, and we were asked to figure out if this was proportional, we'd look to see if there was a constant rate of change throughout the whole table. So what are we multiplying X by to get Y? We're multiplying 1 times 3 gives me 3. So 2 times what gives me 6? Oh, 3. 5 times what gives me 15, so 3. So this is a proportional relationship, okay? Now, if for some reason down here we were to put 6 and 12, what would you multiply 6 by to give you 12? That would be 2, so that would not be proportional, okay? So it has to have the same constant rate of change throughout the entire table. Now, the next way is you could look at a graph. In order for a graph to be proportional, in order for a graph to be proportional, it must pass through the origin and be a straight line. Okay? So, 2 things. It must be a straight line through the origin. The reason why it's straight is because if it has a constant rate of change, anything that's remaining constant is a straight line. Like, for instance, if you were not driving the same speed, your graph of that would look like you were speeding up and slowing down. It wouldn't be straight. But if you're driving at the same constant speed, your graph of that would be a straight line. The reason why it passes through the origin is because at 0 time, you have driven 0 miles. So it's got to go through the 0. At 0 hours, you've earned 0 money. So it's got to go through that 0, 0 to be proportional. Okay? And the last way is you can look at an equation. An equation of a proportional relationship is in the form y equals kx, where k is the constant of proportionality. Okay, so for example, y equals 1/3 x. 1/3 is the constant of proportionality, or it's the unit rate. Okay, y equals 6x. 6 is the constant of proportionality, or the unit rate. Okay, so that's one more important thing we need to write down. I have more room at the top, so let me write that. Unit rate and constant of proportionality are the same thing. Are the same. Basically, unit rate finds out how much per one. Constant proportionality is figuring out what's the constant rate. They're the same thing. Okay? So, tables, you want to have the same rate throughout. A graph must be straight and through the origin. An equation is always in the form y equals kx, where that k, that number you're multiplying by x, is the constant of proportionality or the unit rate. Okay? So I'm going to do a practice problem with you. This first one, you are guaranteed, I could tell you for sure, you're probably going to see a problem just similar to this on your calculator inactive section. You're going to have a table. And guys, these are so easy that you hope you find one like this because you know you can do it. Okay, when you look at this table, the table shows how much a store charges for a certain number of pencils. Based on the table, which equation could be used to calculate the cost C of any number of pencils? So anytime you're given a table, basically these are your X and these are your Y values. So we're trying to figure out what are we multiplying X by to get Y. So one way to work backwards to figure out what you're multiplying X by to get Y is you can always divide. Y divided by X. And you can choose any of those. For me, I start with the first one. So 72 cents divided by 4 pencils. So 4 doesn't go into 0. 4 goes into 7. One time, 4 times 1, 4. 7 minus 4 is 3. Bring down my 2. 4 goes into 32 18 times. And you can always check another one just to make sure. 126 divided by 7. 7 goes into 12 one time. 7 goes into 56 8 times. Okay? So that means each of my pencils are 18 cents. So basically, what are you multiplying? If this is my P and this is my C, am I multiplying the number of pencils times 18 cents or the cost times 18 cents? You're multiplying the number of pencils so that your cost equals 18 cents times the number of pencils. That means you could figure out, if you wanted to know how much 10 pencils cost, you could always plug in 10 where the P is and figure out what your cost would be. So my equation is B. Now, please note, does this look like what we said the equation would look like? Y equals kx? Yeah, it's just not a y and a k, it's a c and a p. So here, my 18 cents, that's how much one pencil costs, so that's my unit rate. And we also said the unit rate is the same as the constant of proportionality. So 18 cents is also my constant of proportionality. Okay? So anytime you're given a table, and if you look, you have several tables on this homework assignment. So you're always going to take the y value, the y side, and divide by the x. Okay, and your equation is usually always multiplying. So, for example, up at this top over here, you're going to take your y and divide by your x. Okay? And do one more with you, and then we'll be done. I'd like for you to look at the back. Over at the right, where it says, look at the line grid below. Find this problem on the back. And it says, which graph shows a proportional relationship? So remember we said to show a proportional relationship, it had to be, if we go back to our notes, in order to be a proportional relationship, it had to be a straight line that goes through the origin. So if we go and we look, well, all of them are straight lines. Which one goes through the origin? B. Okay, so it must be straight and through origin. All right, guys. So for the remainder problems, you're going to go and you're going to work through these, and I will be coming around to help. Please, if you get to one you're stuck on, go back to the beginning where the notes are and read and determine how you can determine if it's proportional. If you're given a table, always divide y divided by x. If you're given a graph, it must go through the origin. And if you're given an equation, it should always be in the form of y equals kx, where k is your constant of proportionality. All right, good luck, guys. Make me proud. Peace out, rainbow trout. Love ya, mean it.